So, this is the second lecture of this course, and this is the first lecture of module 1, that is soil exploration. So, before we in the first class, as I mentioned that it is very important to know the behavior of the soil or the properties of the soil for design of the foundation. So, we should know what is the property of a particular site where this foundation has to be constructed. So, in that way you have to go for the field test as well as the laboratory test, and this collectively all this test and methodology that will be discussed in this module 1, that is soil exploration. So, before we start, what is soil exploration, that should know the definition obviously of the soil exploration. The field and laboratory investigations required to obtain the necessary data for the site for proper design and successful construction of any structure is collectively called as soil exploration. The choice of foundation and its depth, the bearing capacity, settlement analysis depend very much upon various engineering properties of the foundation soils. So, we should know the various engineering properties of the foundation soil before we start the design of the foundation soil. As I mentioned, the strength properties, that means C5 is a very important properties for the foundation design, of important properties of the soil for foundation design. Similarly, for the settlement calculation also, that consolidation properties of the soil, that also very important properties that we should know for the foundation design. Now, the primary objects of the soil explorations are the determination of the nature of soil deposit of the soil, determination of the depth and thickness of various soil strata and their extent in horizontal direction. So, what is the depth and what is the thickness of the various soil strata, that is very important for any foundation design. The location of groundwater table, because groundwater table also play a very important role. So, obtaining soil and rock sample from various strata, the determination of the engineering properties of the soil and rock strata that affect the performance of the structure, and determination of the in situ properties by performing field test. So, these are the objectives of soil explorations. Now, before we go for the soil exploration, we should know what are the soil data required. So, data is required, as I mentioned, that means the soil profile, that means the thickness and soil identification, that is important. Then the index properties. The index properties mean that in the first lecture I mentioned about the index properties like water content, aerobic limits, etc. Then strength and compressibility characteristics, or that means the C dash cohesion, then the cohesion, then undrained cohesion of the soil, phi dash friction angle or internal friction angle of the soil, angle of then the CC compression index, OCR and over consolidated ratio. So, these things we should know. Then other is the location of the groundwater depth, the groundwater table where it is located. Then first stages of site investigation. So, for the look for the currently available information, what are the information available before we start our soil exploration. Then the aerial photographs, if it is available, we will collect that. Then topographical maps, if it is available. Then existing site investigation report for nearby site, if any nearby site, if the existing site investigation report is available, then also we will collect these things. So, we will collect these things before we start our soil exploration. Then first we will go for the site reconnaissance. So, we will go for the preliminary survey of the land of the site where we will conduct the soil exploration, and then we will look at that whether the site access, because we have to we need the access of the site for some for equipments which will be used for soil exploration. So, we will look at the site access, then the topography of the site, then site geology and condition of the adjacent structures. So, if structure is very close to the soil exploration site, then you have to take some precaution, because during the soil exploration the noise will be there, some disturbance will be there. So, if that will affect the structure, then you have to take the precaution for that structure also. So, you have to, and then the condition of the structure, that you have to study nearby location of the site. Then the methods available for the soil exploration may be classified as follows: the direct method, semi-direct methods and indirect methods. Then the direct methods, that is the test pit, trial pit or trenches. Then semi-direct methods, that is boring. Indirect method is sounding or penetration test and geophysical methods. So, one by one I will explain all the methods. Then the direct method or the test pit. The test pit or trench are open type of accessible exploration method. So, that means here it is a open trench or open pit, a test pit we construct, and then it will construct at the level of the foundation where you will place that. So, from there we will collect the soil sample. So, that means the soil can be inspected in natural condition. The necessary soil sample may be obtained by sampling techniques and used for finding strength and other engineering properties by appropriate laboratory test. Test pit are considered suitable only for small depth up to 3 meter, and cost of these increases rapidly with depth. So, this type of direct method by test pit or trenches is suitable for a very small depth up to 3 meter, because we have to construct the trenches up to the at the level where we place the foundation. Now, for greater depth, lateral support or bracing of the excavation will be necessary. So, lateral support or bracing system will be necessary if it is depth is high. So, the cost will increase rapidly for a higher depth. So, test pit are usually made only for supplementing other methods or for minor structures. Now, semi-direct methods or boring. Now, boring, making or drilling boreholes into the ground with a view to obtaining soil or rock samples from the specified or known depth is called boring. Now, common method of borings are auger boring, wash boring, rotary drilling and precaution drillings. Now, what is auger boring? Now, the soil auger is a device that is useful for advancing borehole into the ground. Now, this is a typical figure of the auger boring augers. So, this is post hole auger and this is the helical augers, and this is the rod which can be attached here to increase the, or we can reach up to the required depth, and that length of the auger we can increase by putting this rod here. Now, auger may be hand operated or power driven. The hand operated augers are used for relatively small depth, less than 3 to 5 meter, where the power driven are used for greater depth up to 60 to 70 meter in case of continuous flight augers. The soil auger is advanced by rotating it while pressing it into the soil. As soon as the soil auger gets filled with soil, it is taken out and soil sample is collected. The soil sample obtained from this type of boring are a highly disturbed sample, because here the sample you are getting is very highly disturbed. The auger boring is convenient in case of partially saturated sand, silt, medium to steep cohesive soils. Now, next type of soil exploration or boring technique is shell and auger. So, this is the auger and this is the typical shell and auger photographs. So, it is used widely in India. The shell called as a sand baler is a heavy duty pipe with a cutting edge. The shell is raised and left fall into the hole. The soil is cut, entered into the tube, which is emptied when it is full. That means, this is the cutting edge and this is a heavy duty shell. So, that is this shell is taken up and then it is fallen into the ground. So, this is a valve, one way valve. So, it open and the soil enter from here to into the cell, and once it is enter, this valve is closed, it cannot go back. So, when this cell is filled by the water the soil, then it is taken out and then soil samples are collected and then again it is put into the borehole. The cell is used when auger boring becomes difficult. Where the auger boring is difficult, then this technique is used. Now, next one is the wash boring. Wash boring is commonly used for exploration in the below ground water table, for which auger method is not suitable. So, as I mentioned that auger boring is suitable for partially saturated soil. Now, if the soil is completely saturated or below the water, then auger boring is not a suitable methods. So, in that case we will go for the wash boring. Now, this method may be used for all kind of soil except those mixed with gravel or boulders. A casing pipe is pushed into and driven with a drop hammer. So, its casing pipe is pushed into soil and then it is driven with a drop hammer. The hollow drill bit is screwed into the hollow drill rod connected to a rope passing over a pulley and supported by tripod. So, that means, this is a typical wash boring arrangement. So, here this is the this casing is this is chopping bit is entered into the soil and this is the pulley and this is the tripod, and here the soil is collected with the wash tap. This is the drill rod, then this is the pump. This is the typical system. So, here it is pushed and driven and this into the soil, and the water jet under pressure is forced through the rod and beat into the hole, and therefore, this water jet loosen the soil at the lower end and forces the soil water suspension upward along with annular surface between the rod and the side hole, and this suspension is then collected in a settling tank where soil particles settle, where and the water overflow from the tank and the water collected into sump is used for circulation again. So, that means, when the soil particles settle down, then that soil is collected for the testing and water is allowed to flow for overflow. So, that this water can be circulated for the this water can be used for the next for the future boring purpose. So, now here as I mentioned that here the water sample which is collected is a mixture of soil and water. So, that means, the water sample which is collected here is highly disturbed sample. Now, the soil particle collected represents a very disturbed sample and is not very useful for evaluating for engineering properties. The wash boring are primarily used for advancing borehole. Whenever the soil sample is required, the chopping bees is to be replaced by sampler. The change of rate of progress and change of color of wash water indicate changes in soil strata. So, that means, the color of soil water mixture will give indication that this is the change in soil strata. And as I mentioned that wash boring is giving highly disturbed sample. So, it is not suitable for determining the engineering properties of the soil. It is basically used for the advancing a borehole, and whenever the soil sample is required, we can replace the bit by soil sampler. Next one is the rotary drilling, that can be used for sand, clay and rocks unless badly fissured. A drilling bit fixed to the lower end of the drill rod is rotated by power while being kept in firm contact with the hole. Drilling fluid or bentonite slurry is used under pressure through the drill rod and it comes up, bringing the cutting of the surface. Even rock cores may be obtained by using suitable diamond drill rod. When soil samples are required, the drill rod raised and drill bit is replaced by the sampler. Next one, the precaution drilling, a heavy drill bit suspended from the drill rod or a cable and is driven into the repeated blows. So, water is added to facilitate the breaking of steep rock or soil. The slurry of pulverized material is applied in the in certain intervals. The method cannot be used for loose sand and it is slow in plastic clay. The formation gets badly disturbed by impact. So, when you are talking about this type of boring, and all the borings that except the auger borings, the drill rod is there and a bit is attached in front of the drill rod, and this drill rod is pushed into the soil and it is driven also, and then this drill bit is help to advance this rod into the soil or borehole, and then whenever this soil sample is required, this drill bit is replaced by the sampler. Now, the type of soil sample, as I mentioned that we can get the soil sample in two types. One is disturbed soil sample, another is the undisturbed soil sample. A disturbed soil sample is that in which the natural structure of the soil gets modified partly or fully during sampling. An undisturbed sample is that in which the natural structure and other physical properties remain preserved. Now, where the disturbed sample will be used, where the undisturbed sample will be used. The disturbed sample will be used for grain size analysis, determination of liquid limit and plastic limit or whatever limits of the soil, specific gravity of the soil solid, organic content determination and soil classification. The soil classification also the disturbed sample will be used, but for the strength properties of the soil, that in the shear strength test, then consolidation test, hydraulic conductivity test, in this test undisturbed soil sample must be used. So, that is mandatory, because this unless we use the undisturbed soil sample, then these properties which we will get from this consolidation test, the hydraulic conductivity or shear strength test, that will be required for the foundation design. So, that we should get the properties in soil's natural conditions. So, that is why we need the undisturbed soil sample for these tests. Now, for the undisturbed soil samples, some conditions we have to follow, that if we get this is the undisturbed soil sample, then what is the requirement, what is the condition will be there. So, required for triaxial consolidation test in lab, that good quality samples are necessary. Now, if this is a sampler tube, so this is a hollow tube. So, it has a inner diameter, it has a outer diameter also, and the area ratio we can determine from this way, that is the outer diameter square minus inner diameter square divided by inner diameter square, and it is expressed in percentage. So, here we can determine, we can measure the inner diameter and outer diameter of a sampling tube, and then we can determine what would be the area ratio. Now, for a good quality soil sample, this area ratio should be less than 10%. Now, thicker the wall of the sampler, this thicker the wall of the sampler tube, greater the disturbance. Then take good care of the transport and handling of the soil sample. Once we collect the soil sample, you have to take care for the transportation and handling of the soil sample, so that the soil do not get disturbed. Now, in the IS code recommendation also, So, one is area ratio, that should be less than 10%. In additional to that, IS code recommends few other conditions for the undisturbed samples. So, here this is a typical sampler tube figure, and here D1 is the diameter, inner diameter of the cutting edge, and D2 is the outer diameter of the cutting edge, and D3 is the inner diameter of the sampler tube, and D4 is the inner diameter, outer diameter of this sampler tube. Now, inside clearance Ci, that we can calculate D3 minus D1 divided by D1 percentage into 100. Then outside clearance C0, we can determine D2 minus D4 divided by D4, and the area ratio here we can determine for this type of sampler tube is D2 square minus D1 square divided by D1 square. So, according to IS 1892/1979, Ci should be in between 1 to 3% for a good sample collection, and C0 usually lies in between 0 to 2%, and air should not be greater than about 20% for steep formation, and whereas for soft sensitive clay air should be less than equal to 10%. So, these are the recommendation given by the IS code. Now, degree of disturbance of a cohesive or rock sample can be estimated by recovery ratio also. So, now once we enter in a soil sample into the soil, sampler into the soil, then the recovery ratio is defined as actual length of recovered sample and theoretical length of recovered sample. So, that means how much soil sample we can, what would be the length of the soil sample we have collected through the sampler, that length, this is the actual recovered length of the sample, and theoretical length is the total length of the soil sampler. So, this is the ratio. Now, for LR equal to 1 means recovered length of the sample is equal to the length of the sampler was forced into the stratum. So, that means if theoretical length of the recovered sample is equal to the actual length of the recovered sample, then this is LR is equal to 1. So, that means if the length of the soil sample we have collected, that is equal to the length of the soil sampler that we have pushed into the soil sample to collect the sample into the soil. So, that length of the sampler is equal to the length of the soil sample we have collected, then that LR ratio will be 1, and LR is if LR is equal to 1, that indicates a good recovery, and if LR is less than 1, indicates the soil is compressed, and if LR is greater than 1, which indicates the soil has swelled. So, a good sample collection or sample will be that one where LR is equal to 1. Otherwise, either soil is compressed if LR is less than 1, or it is swelled if LR is greater than 1. So, both are a disturbance is there in these two cases, whereas if LR is equal to 1, which is less disturbance is there. So, that means what are the different types of soil samplers. So, what are the different types of soil samplers? So, the two types of soil samplers, one is thick wall samplers, that is a split spoon samplers, another is thin wall samplers where it is shell by tubes. Now, split spoon samplers is a driven shoe attached to the lower end serves as the cutting edge. So, this is the typical sampler tube. So, here is the cutting edge, this is for the split spoon sampler, and a sample head may be screwed at the upper end of the split spoons. The standard size of split spoon sampler is 30 mm internal diameter and 50.8 mm external diameter. So, this is 50.8 is the external diameter and 35 millimeter is the internal diameter. The sample is lowered to the bottom of the borehole by attach the drill rod. The sampler is then driven in by forcing into the soil by blow from the hammer. So, sampler is attached with a drill rod, and then drill rod is the sampler is placed at a required depth, then hammer is applied on the drill rod, so that the sampler tube can be pushed into the soil. So, once the sampler is pushed into the soil, then the assembly of the sampler is extracted from the holes, then it is taken out from the hole, and the cutting edge and coupling at top are unscrewed. The two halves of the barrels are separated and sample is then collected. The samples are generally taken at interval of 1.53 meter or 5 feet. So, once this soil sample is pushed into the sampler is pushed into the soil sample, then after that it is taken out and soil is entered into the soil sampler. So, once it is taken out, then it is basically a two halves hollow tube. So, it is opened and then soil sample is collected inside the tube. Now, as I mentioned that the external diameter of the soil sample is the split spoon sampler is 50.8 and internal diameter is 35 millimeter. So, what would be the area ratio, that is 50.8 square minus 34.9 or close to 35 millimeter, or it is close to 35, actually 34.9 millimeter. So, that is the area ratio is 112%, whereas for the good sample the area ratio should be equal to or less than 10%, but it is 112%. So, the split spoon sampler is highly disturbed, the sample which is collected by split spoon sampler is highly disturbed sample. Now, when the material encountered in the field is sand, so that means here we are talking about that we will get the sample from the split spoon sampler, it is suitable for the standard one, it is suitable for the clay soil. Now, if we encounter for the sandy soil, then a partially fine sand below the water table, a device such as spring core catcher is placed inside the split spoon. So, that means this is the spring core catcher which is placed, this is the normal split spoon sampler which is used for the clay soil, and if it is sandy soil or below the water table, then a split spoon, this is the spring core catcher, this one is fixed in the split spoon sampler. Now, the thin wall, that was the previous one was the split spoon sampler or thick walled sampler. This is the thin walled sampler tube, commonly used to obtain undisturbed clay sample. So, previous one is obtained for disturbed sample, because there the area ratio is 112%. But here this commonly used for undisturbed clay sample. The outside diameter is 50.8 millimeter and 76.3 millimeter, the two types of samples. The sample with a 50.8 millimeter outside diameter has an inside diameter of about 47.63 millimeter. So, then the area ratio is coming out to be 13.75%, which is very close to 10%. So, that means the for the good undisturbed soil sample collection, the area ratio should be around 10% or less than that. So, here it is around 13 or 14%, which is close to 10. So, this is generally used for the collection of undisturbed clay samples. So, this is a typical thin well sampler photographs, or which is used for the collecting undisturbed sample. Now, how many boreholes will decide that for a particular site, how many boreholes will be there, how will decide. So, that the number of boreholes depend on the type and size of the project. now budget of the site investigation and soil variability. Now, if the type and size of the project depending upon that will decide how much, what is the number of borehole will, from where we will take the soil sample. If the site investigation budget is more, then we can definitely go for a higher number of boreholes, and if the budget is less, then you have to go for the lesser number of boreholes. And if the soil variability, if the soil variability in different boreholes is very very much, then we have to decide, then we should increase the number of boreholes for a particular site. So, locate the boreholes where loads are expected. Then the spacing of boreholes. So, initially was the number of boreholes, then the spacing of boreholes, then the depending upon the type of project. So, what is the spacing, that the multi-storied buildings, the spacing should be 10 to 30 meters, or that is one story industrial plants 20 to 60 meter, highways it is 250 to 500 meters, residential subdivisions 250 to 500 meters, and dam and dikes 40 to 80 meters. So, this is the typical spacing can be used for different type of structures. Now, the depth of boreholes, what would be the minimum depth of boreholes? So, now first we have discussed the number of boreholes, then the spacing of boreholes, now the depth of borehole, up to what depth we will collect the soil sample. So, that is very important issue. Or generally the influence zone of a foundation is generally taken as the twice of the width of the foundation. So, that is a thumb rule, that the twice of the width of the foundation is generally taken as the influence zone. So, that but there are some recommendations there by which we can determine what would be the minimum depth of the boring. So, first one is the given by ASC 1972 here. So, suppose this is a foundation and D is the depth of the borehole from the ground. Now, here first determine the net increase of stress under the foundation. So, net increase, what is the increment of stress due to this applied load at the foundation level. So, at the foundation if we applied load, what would be the net increment of stress at different depth. So, that we can calculate, and for this calculation various equations are available. So, and in the later on when you calculate the settlement, or then we will show how to calculate this increment of the stress due to the applied load at different level. So, that is the net increase in the stress, then estimates the variation of vertical effective stress with depth. So, that means here we can see the vertical stress, effective stress will increase as we will go in depth. So, that means with depth it is increasing, and for the net increment of the stress is decreasing with depth. So, this is the vertical effective stress that is increasing, and this is the net increment of the stress due to the applied external load, and that is decreasing with the depth. Now, determine the depth d is equal to d1 at which stress increase delta sigma is equal to q by 10, where q is the estimated net stress on the foundation. Now, here what is q? Q is the net stress applied at foundation level, that is q, and then we determine the depth d1 at which this net increment of the stress del sigma is 1/10 of the net stress applied at foundation level. So, we determine that depth as a d1. Then we determine the depth d is equal to d2 at which the ratio net increment of stress divided by effective vertical stress is equal to 0.05. So, that means we will determine that depth also, where we will get this condition. Now, unless bedrock is encountered, the smaller of two depths d1 and d2 will be the approximate minimum depth of boring required. If we encounter the bedrock in between these two, then we have to go for the up to the bedrock, then that is okay. But if the bedrock is not encountered, then smaller of these two depths will give us the approximate minimum required depth of boring. Now, another way that we can get the depth of boring by this recommendation, boring for a building with a width of 100 feet or 30.5 meter. That this is a one particular case which is shown here, that the number of stories, if it is 1, then the boring depth is 3.5 meter, and if the number of stories is 2, then the boring depth is 6 meter. If number of stories is 3, then the boring depth is 10 meter. If number of stories is 4, then 16 meter. If it is 5, then it is 24 meter. So, this is a typical example is shown here. Now, depth of boring according to IS code. So, according to IS code, what would be the depth of boring? So, that is IS 1892 1979. So, according to that, what would be the depth of boring? Now, if the type of foundation, if it is a isolated spread footing or raft, the depth of boring will be 1.5 times of the width of the foundation. Then this is the minimum required of the depth of boring for the isolated spread footing or raft foundation. This is 1.5 times the width of the foundation. Now, if adjacent footing with clear spacing less than the twice of the width, then also 1.5 times the length of the footing. Then if it is a pile and well foundation, then to a depth of 1.5 times the width of the structure from the toe of the pile of the bottom of the well. So, that means from the bearing length. So, if it is a pile or well foundation, to a depth of 1.5 times the width of the structures from the bearing level or that is the toe of pile or bottom of the well. For example, that if it is a pile foundation, so this is a pile foundation and say this is pile cap. So, generally it is saying that if this is the width of the structural width of the pile cap, then from this bearing we can go 1.5 times with the width of the structure, that is from the toe of the pile or bottom of the well will go. So, that will be the minimum required depth of the boring. This also has this depending upon the type of the soil, also this depth will change. So, later on in the calculation of pile settlement we will see that up to which will be the influence zone, up to which depth depending upon the different types of soil. So, influence zone where will take up to which depth will take the influence zone, that will also change. So, but the typical rule is that width of the structure is B, then from the bottom of the pile or well go up to 1.5 times of the width. Then next one is the road cut, that equal to the bottom width of the cut, and then fill, if it is a fill, then 2 meters below the ground level or equal to the height of the fill, whichever is greater. Then we have some other condition also, that is the IS code also recommends some other conditions of the depth of the boring. So, if this is two building structures, if this is width of the one width is B and another one is B and there is a gap A. Now, if L is greater than equal to B, then depth of the boring will be 1.5 times of the B for A equal to greater than equal to 4 B. So, this is another one, depth of boring is 1.5 times of L for A is less than twice of B. So, this is one condition. Now, these are the some building dimension or building blocks are there, and this is the total width W, this one L is equal to W, this width is B, this spacing is A, again B, A, B. Now, depth of boring will be 4.5 times of the B for A less than twice B, and depth of B boring will be 3 times of B for A greater than twice B and less than 4 B, and depth of boring will be 1.5 times of B for A greater than equal to 4 B. The next one is the we should know the location of the water table also. As I mentioned, the location of water table is also a very important issue, because we should know that what would be the location of a particular water table, because as the position of the water table changes, the load carrying capacity of the foundation or the soil, then the settlement of the soil, that will also change. So, before we design the foundation, we should know what would be the location, what is the location of the water table. Now, to locate the water table, the correct indication of groundwater table level is found by allowing the water in a boring to reach a equilibrium level. So, that means for how we will get the location of the boring. So, water table. So, we can construct a borehole and then we can pour water into the borehole and allow this water to settle down. So, that means the correct indication is after some time we will get the water table will reach a equilibrium condition. So, that water within the borehole will reach a equilibrium condition. So, after that there will be no change of the water level. So, that equilibrium condition or equilibrium level will indicate that that is the level of the water table. Now, if the sandy soil, if the soil is sandy soil, the level gets stabilized very quickly within a few hours at most. But if it is a clayey soil, for the sandy soil this water will take the equilibrium condition very quickly, that means within an hour. But if it is a clay soil, then it may take a day, many days for this purpose. Hence, the standpipe or piezometer are used in clay and sand. So, for the previous method that is suitable for the sandy soil, because it takes very less time, say a few hours. But if it is a clay soil or silty soil, then it takes very long time, say many days. So, that is why that method is not suitable for the clay, or in that case the piezometer or standpipes are used to determine the location of the water table. So, in this way we can determine the various engineering properties for, but today's class I have discussed about only discuss the direct method and semi direct method. I have not discussed about the indirect method or indirect method, that means the penetration test or geophysical exploration. So, those things will be explained in the next class. So, today's class we have discussed about the direct methods and the semi-direct methods, then what are the different types of soil samples. So, what are the different types of soil samples, that is the disturbed soil samples and undisturbed soil samples. So, where we will use those soil samples. So, that means we will get in the boring methods or semi-direct method, we will get all the disturbed samples. So, where you will use those disturbed samples. So, that means the determination of some properties, say index properties or the soil classification, we can use the disturbed sample. But if it is in case of strength properties or the consolidation properties or the hydraulic conductivity test, in that case we cannot use the disturbed sample. In that case, use of undisturbed sample is compulsory. We should use the undisturbed sample in those cases, because those properties are very important for foundation design. Next one is that how we will get the disturbed sample, undisturbed sample, how we will collect the undisturbed sample, what is the condition of a collecting of good quality soil sample. So, for the good quality soil sample, we should use the sampler tube whose area ratio is less than equal to 10%. And IS code also have recommended some other conditions. Those things have already been explained in this class. So, in this lecture. So, that means we should use a soil sampler whose area ratio is less than equal to 10%. And generally for the sampler, there are two types of samplers are used. One is thick wall sampler tube, that is a split spoon sampler, another is thin wall or shell bite tubes. And as it is expected that if we increase the thickness of the sampler tube, because sampler tube is a hollow tube, if we increase the thickness, there will be more disturbance. So, in the split spoon sampler tubes, have seen that the area ratio is 112%. So, if we use the split spoon sampler tube to collect the soil sample, then that soil sample will be a very highly disturbed sample, because where the area ratio is 112%. So, whereas if we use the thin walled sampler tube or the shell bite tube, there the area ratio is around 10%, that is 13.75% for a particular case. So, that means that tube we can, that sampler tube we can use for collecting the undisturbed soil sample for clay. Now, the question is that once you collect the soil sample, then what would be the number of boreholes, that we have to also decide. So, where we will, so that the first condition is the where the maximum load is expected, we have to locate a borehole there. And again, what would be the number of borehole, that depends on the type of structure for which we are doing the soil exploration, then the budget of the soil exploration. If budget is more, we can provide more boreholes, and if the budget is less, then we can provide, we have to go for the lesser amount of the number of boreholes. And another issue is the soil variability. So, if the variation of the soil sample is more in different boreholes, then it is required to use more boreholes in the proposed area, so that we can get the proper soil properties of the that location. So, once we decide the number of boreholes, next we will decide the spacing of boreholes, what would be the required spacing of. So, there also we have discussed some guidelines for different types of structure or different type of construction, what will be the minimum spacing between the boreholes. Next one is the very important issue is the depth of the boreholes, up to what depth we will go for our soil sampling. So, that also depending the type of structure we are constructing over there, and what would be the width of the structure, and based on that width we can determine what would be the required minimum depth of the boreholes. And again for that purpose also we have explain, I have explained one recommendation proposed by AC, by which also we can determine which will be the minimum requirement of the depth of the borehole. Another one, some typical example for a particular 100 feet width of building, for different number of, as the number of stories increases, the depth of borehole is also increasing. So, that is also be explained there. The next one, another for the IS code recommendation also is given. So, typically for a foundation, if it is a width is B say, then the depth of borehole, if it is a shallow foundation or raft foundation, say if it is a depth width of the foundation is B, then typical minimum depth of the boreholes is varies from 1.5 times to 2 times of the width. So, that means the generally it is taken up to 2 times of the width of the foundation soil is influenced by the stress which is coming from the foundation, that means the external loading. And generally when you design the foundation, you will design for the two criteria. One is for the bearing capacity criteria and another is the settlement criteria. Now, for the bearing capacity criteria, we take the soil properties up to the twice B, up to the B sorry. For the bearing capacity calculation purpose, we take it is up to the B of the up to the B of the soil layer. So, that means, so here if B is the width of the foundation, then we take the soil properties of depth below the foundation level up to the width B. So, depth is equal to B. So, up to that portion we take the soil properties for the bearing capacity calculation, but for the settlement calculation generally we take the depth of the foundation soil depth up to the depth of the soil layer below the foundation base is equal to twice of the width of the foundation. So, in that way we can so that means at least up to twice of the width of the foundation you have to go for the depth of boring, and for the that is for the shallow foundation. For the deep foundation for pile or for the well foundation, again you have to go for the 1.5 times to 2 times of the width of the structure, but that is from the base of the pile or tip of the pile or below the well of the well up to 1.5 or twice the width of the structure. So, that way we can determine, and also IS code has recommended some guidelines. So, those things also been explained in this lecture, the what would be the minimum depth of the boring. And then the next one is the location of the water table, that is also very important issue. So, that means we should also should know that what would be the location of the water table. So, these are the things very important for the soil exploration. So, we should know these things before we start the foundation design. So, in the next class I will explain in the lecture 2 what the indirect method, that means the penetration test, and then the geophysical explorations. Thank you.